Okay, take a look at this little Venn diagram we drew on the board here, and hopefully this can help you understand the different sets of numbers that we'll be dealing with. And you're going to need to classify numbers based on which set they belong to. Okay, now the way you look at this, all numbers that we're going to deal with in this class fall under the set of real numbers. When you get to other math classes, you'll learn about another set of numbers called the imaginary numbers. But for 8th grade math, what you need to know is that all the numbers we'll deal with in this class fall in this set of real numbers. Okay, now the set of real numbers can be broken up into two categories: the rational numbers and the irrational numbers. We talked a little bit about these two sets last week, or earlier this week. Irrational numbers cannot be written as fractions, and when they are written as decimals, they don't terminate and they don't repeat. So what are the examples of irrational numbers? Pi is the most famous irrational number of all time. It's a decimal, you know, it does not terminate, it does not repeat. The other place you find decimals that don't terminate and don't repeat are most of your square roots. The square root of 63, the square root of 2, the negative square root of 8. Those are all going to be irrational numbers. Their decimal expansion does not terminate, does not repeat. Okay? Which then takes us over to the set of rational numbers. Rational numbers, we said, remember, can be written as fractions, like 7 over 8, negative 22 over 4. That's a fraction, therefore it's rational. And rational numbers, when they are written as decimals, one of two things happen. The decimal either terminates, like here on 3.8, or the decimal will repeat, like 2.33333, which we write as 2.3 repeating. So the rational numbers, within the rational numbers, you have the set of integers. Now integers is made up of the set of whole numbers and their opposites. Whole numbers start at 0 and go up from there. So 0, 1, 2, 3, 4, 5, and so on. Notice the square root of 4 is in the set of whole numbers. That's because 4 is a perfect square. The square root of 4 is 2. 2 is a whole number, it is also an integer, and it is also a rational number. So anything in the whole number category also falls into the category of integers, and it also falls into the category of rational numbers. And of course, all numbers in this class are real numbers. So as you start to classify numbers, you want to think about which sets the number belongs to. For instance, 2.4 is not an integer or a whole number because it has the decimal. However, it is rational because it is a terminating decimal. Hope that helps.